CSC159. Computer Organization. Chapter 3, The CPU and Memory, Organization, Part 1. Book of Reference, Credit to The Architecture of Computer Hardware and System Software. An Information Technology Approach. 3rd edition, IRV Englander. By John Wiley and Sons 2003. The subtopic Part 1 will cover 3.1 Microprocessor Architecture. The components of the CPU. Control Unit, or CU. Arithmetic Logic Unit, or ALU. Registers. Bus, and System Clock. 3.1 Microprocessor Architecture. In most computer systems, the CPU, memory, and other major components are mounted to wiring on a printed circuit board known as a motherboard. CPU or processor. Contained on a single integrated circuit called a processor, or microprocessor, that is located on the motherboard. Known as the heart of a computer. Functions. Execute programs stored in the main memory by fetching their instruction. Decoding. Translate the program instruction into the commands that computer can process. Execute them one after another and store back into main memory. Contains 3 major components. First, Control Unit, or CU. Second, Arithmetic Logic Unit, or ALU, and third, Memory. CPU, 3 major components. CPU fetches the input instructions or commands from the memory unit, performs arithmetic and logic operations and stores this processed data back to memory. System block diagram. A simplified conceptual block diagram of a CPU with memory is shown in this figure. As noted before, the computer unit is made up conceptually of 3 major components: the arithmetic logic unit, or ALU, the control unit, or CU, and memory. The ALU and CU together are known as the central processing unit, or CPU. An input-output, or I/O, interface is also included in the diagram. The I/O interface corresponds in function roughly to the input and output baskets. CPU machine cycle. A machine cycle consists of the steps that a computer's processor executes whenever it receives a machine language instruction. Modern CPUs are able to perform millions of machine cycles per second. The cycle consists of 4 standard steps. Step 1. Fetch. Obtain program instruction or data item from memory. Step 2. Decode. Translate the program instruction into commands that computer can process. Step 3. Execute. Carry out command one after another. Step 4. Store. Write result into main memory. CPU, 3 main sections. CU, or control unit, performs fetch-execute cycle. CU is the brain of the microprocessor. CU functions are to move data to and from CPU registers and other hardware components, no changes in data. To access program instructions and issues commands to the ALU. ALU, or Arithmetic Logic Unit. ALU is the heart of the microprocessor. It performs calculations and comparisons. Data is changed. Registers. Example of registers: program counter, PC, or instruction pointer that determines next instruction for execution. Control unit, CU. CU interprets and controls the execution of instruction. Performs fetch-execute cycle. CU issues the signals necessary to control operations of the microprocessor. CU is responsible for sequencing the actions, where it controls what registers and devices are to be enabled, and when they are to function. The control is achieved through a structure called control bus, carry control signal. Subparts of the CU are memory management unit, that supervises fetching instructions and data. I/O interface, sometimes combined with memory management unit as bus interface unit. CU, continued. To determine which instruction to be executed, CU reads the contents of the program counter, PC, or instruction pointer, IP. The instructions are then decoded by the instruction decoder in the CU. Instructions are executed sequentially. CU, continued. Instruction decoder is part of the CU. But the decoding of instructions is a separate and distinct phase of microprocessor operations. The microprocessor knows how to add, but does not know when to add and what to add. When an instruction is fetched from the memory, the instruction is then sent to the instruction decoder to be decoded or interpreted. Control signals will then be issued to perform the necessary operation. The interpretation process is called instruction decoding. Arithmetic Logic Unit, ALU. ALU performs calculations and comparisons, data is changed, and arithmetic logic operations. In short, ALU performs arithmetic operations such as addition and subtraction, division, and multiplication. All logic operations such as AND, OR, XOR, etc. ALU, continued. Components of the ALU are comparator, that compares the magnitude of two numbers placed in the buffer register. Works in conjunction with status registers to display result of the comparison. Logic registers, that perform the logic operations. Shifter, that moves the content of the register one or more positions to the left or right, perform rotate operation. Operation of ALU is controlled by the control signal to facilitate the sequencing and operation of each individual block. Register. Register is a single, permanent storage location within CPU used for particular, defined purpose. It holds binary value temporarily for storage, manipulation and/or for simple calculation. Manipulated directly by the CU during execution of instruction. The various types of registers are data registers, address registers, and status registers. General purpose registers are also known as accumulators. Are considered to be a part of the ALU. The usage are: it holds data used for arithmetic operation and the result, and it is used to transfer data between different memory, and between I/O and memory. Concepts of registers. Small, permanent storage locations within the CPU, used for a particular purpose. Manipulated directly by the control unit. Wired for specific function. Size in bits or bytes. Not in megabyte, MB, like memory. A register may hold data being processed, instruction being executed, memory or I/O address to accessed. Keeps track of the status of the computer or conditions of calculations. Use of registers. Scratchpad for currently executing program. Holds data that is needed quickly or frequently. Stores information about status of CPU and currently executing program. Address of next program instruction. Signals from external devices. Special purpose registers. Program counter register, or PC. Also called instruction pointer. 16 bits wide, must be able to hold an address of the next instruction to be executed. Since programs are normally carried out sequentially, the counter portion of the device generates sequential address numbers. Instruction register, or IR. Stores instruction that is fetched from memory, the actual instruction currently being executed by the computer. Memory address register, or MAR. Used for addressing purpose, hold the address of a memory location. At least 16-bit wide. Several types, index, page, and stack registers. Special purpose registers. Memory data register, or MDR. Also known as memory buffer register. Hold a data value that is being stored to, or retrieved from the memory location currently addressed by the memory address register. Status registers. Status of CPU and currently executing program. Flags, 1-bit Boolean variable, to track special condition like arithmetic carry and overflow, power failure, internal computer error. Several flags are grouped into one or more status registers. Each bit in 8-bit status register has specific meaning in relation to the result in the ALU. Input-output register. Hold the input-output data and address that addresses a particular input-output devices. Register operations. Stores values from other locations, registers and memory. Addition and subtraction. Shift or rotate data. Test contents for conditions such as 0 or positive. Bus. The physical connection that makes it possible to transfer data from one location in the computer system to another is called a bus. Bus is a parallel electrical line or paths connecting a source to a destination. Is a common path used for specific exchange of data between various block functions. Can be on printed circuit board or parallel connected wires in a ribbon cable or conductive paths etched on the microprocessor chip. System clock. Microprocessor must perform all operation under a very strict timing sequence. The CU utilizes the system clock to synchronize or control the timing of all computer operations. The system clock generates electronic pulses, ticks, at a fixed rates and measured in megahertz, 1 megahertz equals 1 million pulses per second. These ticks are called cycle. An instruction cycle begin when the address for retrieving an instruction from memory is placed on the address bus for fetch, and ending when the execution phase is complete. Summary. At this point we have explored the CPU or microprocessor, the buses that connect everything together, and the clock that controls the operation of the CPU. Actually there are other components that make up a computer system such as primary storage, I/O modules, and various I/O devices. There are various ways to interconnect the CPU, memory, and I/O peripherals, each with their own advantages and disadvantages. The blocks that make up the essential components of a personal computer or workstation are shown as a simplified diagram in this figure. Class exercise. Past year exam, October 2012, Part B. Question 2. Past year exam, December 2018, Part B. Question 5. This is the end of Part 1. Thank you everyone.